Dear students, yesterday we discussed the limit of the function f of x equals to x plus 1 at x equals to 0. Now today we are going to discuss the function f of x equals to x square, and we will find its limit at x equals to 1. In this function f of x equals to x plus 1, the limit exists and the value of the limit is 1 at x equals to 0. Here x equals to 0 or simply 0 is not in a domain of f, or simply we can say that the function is not defined at x equals to 0, although the limit exists at x equals to 0. Now here we will check, or we will find the limit of this function where the function is defined. Because x equals to 1, here the function is defined. Now we will check the behavior, or we will check the value of the function at the points which are closer to 0 from left side and right side. Now from left side the points are 0.9, 0.99, 0.999, so on. So there are infinitely many points which are closer to 0 from this left side, and the value of the function at these points, that is at x equals to 0.9, the value is 0.81, at 0.99 the value is 0.98, and at 0.999 the value of the function by substituting in x square, it is 0.99. Now this statement, all these points are very close to as this one from left side, so this means that we can say that this x tends to 1 negative, that is whenever we approach to x, this one from left side, the value we get here it's 0.81, 0.99, 0.99. So this means that when we approach to 1 from left side, the value gets closer and closer to 1, because 0.81 is less than 0.98, is less than 0.99, it is less than 0.999, so on, and ultimately we will reach at not exactly at 1 but near to 1. So this means that the value of the f of x approaches to 1. This we can simply write this as x tends to f of x tends to 1. So this one is called here as the left limit. Similarly, points from right side are 1.1, 1.01, the 1.001, 1.0001, which is nearest to this 1 as compared to 1.0 or 1.1. Now the value of the function at these points is simply 1.21, 1.02, 1.002, 1.0002, so on and so forth. So this means that when we are approaching to this one from right side, the value of this one gets closer and closer to 1. That is fx gets closer and closer to 1. This means that when x tends to 1 positive, f of x tends to 1 from which side? From right side. So this is simply called as the right limit. But yesterday that when the left limit equals to right limit, and the common value is simply called as the limit, that is left limit is here right limit, which implies that we can say that limit x tends to 1, f of x is 1, or when x approaches to 1, f of x approaches to 1. So this means that 1 is the limit of this function at x equals to 1. Now graphically we can say clearly x square, it is parabola, it. Now at x equals to 1 here, if we consider this, here it is the domain point, x equals to 1, x equals to 1. Now these are the points which are closer to this one from left side, and at these points the value of the function gets closer and closer to 1. Similarly from this side the points are 1.01, 1.1, 1.12, so on and so forth. The value gets, or value approaches to 1 from this side. So this means that when we approach from this side, the value gets here value approaches to 1, while when we approach to 1 from this side, still here the value approaches to 1 but not equals to 1. That is why this approaching is simply the limit, and the limit here is 1. So from this we conclude that for any function f and for any point as x tends to a, here tends means we are approaching to a from two sides, the value of the function should approach to a fixed number, say L, then L is called simply as the limit, and we denote simply it by when x tends to a, f of x equals to L, or when x tends to a, f of x tends to L. For existence of limit, right limit should be equals to left limit, because on number line, why we have two limits on this real number for real functions? Because if we consider any point on number line, there are two ways to approach this, or we have two ways to reach at point A, one from left side and one from right side. Left side is called as the negative limit or simply the left limit, and from right side, when x tends to A positive from right side, this is we get here the right limit. That is, x tends to A negative is L1, x tends to A positive is L2, right limit. When L1 equals to L2, we simply say this is the common value is the limit of the function at the given point. Now if we consider another function, f of x is defined by f of x plus 1 when x less or equals to 0. So this means that the function for all the points which are less than or equal to 0, the function is defined by x plus 1, and for the points the function is defined by 2x which are greater than 0. So the points from left side are minus 0.1, minus 0.01, minus 0.001, and the value of the function is 0.99, 0.999. This means that when x tends approaches to 0 from negative side, the value approaches to 1. Similarly, the points closer to 0 or the close to 0 from right side are 0.1, 0.01, 0.001, so on, and the value of the function at these points is 0.2, 0.02, 0.002. Now this 0.2, 0.02, 0.002, this means that when we reach towards this 0, the value gets closer and closer to 0. This means that the right limit, that is x tends to 0 positive, tends to 0, that is f of x tends to 0, which implies that right limit is here 0. So this means that left limit is not equals to here right limit, hence we can simply say that limit of this function at x equals to 0 does not exist. In this function, x equals to 0 is a domain point. So this means that there are the functions where the function does not exist at a point or at a point where the function is defined. But if we consider this example x plus 1, which we discussed in the previous lecture, limit exists, that is 1, at x equals to 0, although x equals to 0 is not in the domain. So this means that existence of limit does not depend upon whether the point is whether the point is in domain or whether the point is in outside the domain. That is, the function is defined at the point where the limit exists, or the function may not be defined at the point where the limit exists. So inshallah, in tomorrow's video lecture we will discuss few more examples. Thank you.